Today I am going to explain about atomic radius. Atomic radius. So what is mean by atom? First of all, you have to know about atom. Atom means it is very tiniest unit of a matter. That means it is not visible. It is very small. The structure of the atom is like this. Nucleus is placed at the center and electrons are revolving around the nucleus in a circular path. So these are the electrons. The electrons present in the inner shells is called as inner electrons and core electrons. The electrons present in the outer shells is called as valency electrons or outer electrons. Right? This is the structure of an atom. So the concept is atomic radius. That means the radius of an atom. How it is calculated? By measuring the distance from the nucleus to outermost shell. Atomic radius is calculated by measuring the distance from the nucleus to outermost shell. This distance, nucleus to outermost shell, this distance is called as radius of that atom. The distance from nucleus to outermost shell, right? Outermost shell. This distance is called as radius of that atom. So, but it is very difficult. Why? Because it is very difficult. Why? Because the difficulty is to measure the radius of that atom. Difficulty 1. Atom of the size is very small size. And the second difficulty is atom does not have sharp boundary. Does not have sharp boundary. So the size of the atom is very small. Why? Because atom is tiniest unit of a matter. It is very small. The size of the atom is very small and does not have the well-defined boundary. Boundary means it does not have the sharp boundary. Electron clouds are always surrounding around the nucleus. So atom does not have the sharp boundary. These are the difficulties. So it is very difficult to find out the radius of atom. However, we can find out the radius of an atom. But atom must be in combined state. Then only we can find out the radius of atom. So atom must be placed in a combined state. That means this is atom 1, this is atom 2. So then find out the radius of atom. The distance from the nucleus of one atom to the another atom is denoted by D. So atoms are placed in some compound. So this is atom A, this is atom B. So the distance from the nucleus of one atom to the another atom is denoted by D. So atomic radius is R is equal to D by 2. So r is equal to d by 2. So then this is the formula for we are using for calculating the radius of an atom. So this is the formula. I am going to explain different types of atomic radius also. So different types of atomic radius: covalent radius, and metallic radius, right? So what I have said, the distance from the nucleus of one atom to the another atom is denoted by d. So r is equal to d by 2. This is the formula for calculating the radius of an atom. So let us discuss about covalent radius and metallic radius. So what is mean by covalent radius? Covalent radius measured in covalent compounds. Covalent compounds. So metallic radius is measured in metallic. So metallic related compounds, right? Metallic related compounds. So what is mean by covalent compounds? For example, A is an atom, B is also an atom. A shares one electron and B shares one electron to form a bond. This bond is called as covalent bond, and this compound is called as covalent compound. So covalent compound means the two atoms bond together by a sharing of electrons. You have to remember this point very clearly. Sharing of electrons always forms the covalent bond. Covalent compounds. That means A atom shares one electron, B atom also shares one electron to form a bond, and these two atoms are bound together by sharing of electrons. Then it is called as a covalent compound, and this bond is called as a covalent bond. This bond is very, very stable and strong bond among all bonds in chemistry. Covalent bond is very, very strong and stable. So we have to find out the covalent radius. So how it is find out? The distance from the two atoms, the bond distance from the two atoms is covalent radius. The bond distance from the two atoms, and half of the distance is called as radius of that atom. So I am explaining another example also. So let us discuss about chlorine molecule. Chlorine molecule. In chlorine molecule, chlorine atom, there are two chlorine atoms. So one chlorine atom shares one electron, another one chlorine atom shares one electron and form a bond. This bond is covalent bond, right? So the bond distance between the chlorine atoms is 198. The bond distance between the two chlorine atoms is 198, and the radius is, the units of radius is pm, picometers. pm, the picometers is units of radius, right? So we have to find out the radius of one chlorine atom. We want that. We want to find out the atomic radius, right? Not molecular radius. We have to find out the atomic radius. That's why the formula is d by 2. That means 198 by 2. That means 99 pm. This is the radius of one chlorine atom, right? This is the way we have to find out the atomic radius. But atom must be in a combined state, not individual state. not individual state. Atom must be placed in a combined state, then we can find out the radius of that atom. So this is covalent radius. Let us discuss about metallic radius. So what is metallic? Metals have the special property, that is electron donors. Metals are always electron donors, very good electron donors, very good electron donors. So metallic compounds and metallic element. What is the difference between the compound and element? Metallic element. Compound means two or more different elements. The combination of compound is two or more different elements. Like example, I am saying NaCl. This is metallic crystal, metallic compound also. And metallic element means copper. Element means same type of atoms. Same type of atoms. Compound means two or more different elements. So sodium is one element, chlorine is also one element. Sodium is metal and chlorine is halogen, right? So two or more different elements. Element means same type of atoms. Copper atom, copper atom. So this is the difference between the compound and element. So copper atom. So copper atom, one copper atom, another one copper atom. This is the half of the distance, half of the internuclear distance separating the metal cores in the metallic crystal. This is the half of the internuclear, that means the nucleus of this copper atom, the nucleus of this copper atom. So half of the internuclear distance separating the metal cores present in the metallic crystal. That means it is denoted by D. So R is equal to the internuclear distances between the copper atoms is 256 pm, right? So R is equal to D by 2, right? So R is equal to 128 pm. This is the radius of one copper atom. This is the way we have to find out the atomic radius. Atomic radius. So generally atomic radius means the distance from the nucleus to outermost shell. But this distance we cannot find out. Why? Because it is very, very difficult. Atom is very small and does not have sharp boundary. It is the size of the atom is very small, does not have the sharp boundary. That's why we can't find out the distance from the nucleus to outermost shell. That's why, but however we can find out, but atom must be in a combined state. Combined state means atom must be placed in a combined state. That means covalent compounds, metallic compounds, ionic compounds, so many are there in chemistry. So all these compounds, atom must be definitely placed in a combined state. So the different types of radiuses, atomic radius. So covalent radius, metallic radius. Covalent radius means measured in covalent compounds. Metallic radius measured in metallic compounds, right? So covalent compound means, so if two atoms bond together by sharing of electrons and forms a bond, this compound is called as covalent compounds. Equal sharing of electrons, then the compound is covalent compound, right? So this bond is called covalent bond. So example of covalent compound is chlorine molecule. One chlorine atom shares one electron Another chlorine atom shares 1 electron. The bond distance between the two atoms is 198 pm. So R is equal D by 2, 198 by 2, 99 pm. Pm is units of radius, right? So this is the 99 is the radius of one chlorine atom. This is the way we have to find out the radius of atom. So next, metallic radius. Same like as covalent radius, but measured in metallic related compounds. So copper. So one copper atom. This is another copper atom. The internuclear distances between D, denoted by D. The internuclear distance between the two copper atoms is 256. So D by 2 is the formula. That's why D 256 by 2 and 128 pm. This is the radius of one copper atom. This is the radius of one copper atom. This is the way we have to find out the radius of atomic. So this is the way we have to find out the atomic radius. So why? Because atom is very small, it is not visible. That's why we can't find out the radius of one atom. We can't find out the radius of one atom. But it is placed in a combined state, then we can find out. Then we can find out radius of one atom. But must be placed in a combined state, not individual, combined state. Atomic radius is changes in groups and periods. We all know that this is a periodic trend. Atomic radius is physical property, right? Physical property. This is physical property. So atomic radius is changes in groups and periods. Groups means the vertical lines of periodic table is called as groups, and the horizontal lines is called as periods, right? In groups, atomic radius is increases from the top to bottom, and in periods, atomic radius is decreases. Why? Because atomic radius is increases from the top to bottom. Top to bottom. Atomic radius is decreases from left to right. Left to right. Let us discuss about this. So, in group 1 atom, alkali metals, right? So, hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. All these are group 1 elements, right? So atomic numbers of these elements 1, 3, 11, 19, 37, 55, 87, right? So electronic configurations of these elements 1s1, 2s1, 3s1, 4s1, 5s1, 6s1, 7s1, right? And here consider the period 2 elements, right? Period 2 elements. So lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So atomic numbers of these elements 3, 4, 5, 6, 7, 8, 9, 10, right? The electronic configuration of these elements 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5 and 2p6. So imagine here you have to observe one thing: 1s1, 2s1, 3s1, 4s1, 5s1. That means number of shells is increases from the top to bottom here. But here you have to observe 2s1, 2s2, that means 2 remains, that means number of shells is remains same in the period. In the groups, number of shells is increases from the top to bottom, that means size is increases from the top to bottom. Obviously the size is increases from the top to bottom. But here size is remains same. Size is remains same from the left to right. This is the difference, big difference between the periods and groups. You have to observe from the top to bottom size is increases. That's why atomic radius is also increases from the top to bottom. But here size is remains the same. So size is remains same means nuclear charge is increases. Nuclear charge is increases. So what is mean by nuclear charge? What is mean by nuclear charge? This is nucleus, right? And electrons are revolving around the nucleus. These are the core electrons. These are the valence electrons, right? So nuclear charge means the net force of attractions between the nucleus and outer electrons. The net attractions between nucleus and outer electrons. So inner electrons feels the attractions of nucleus completely, and it prevents, the inner electrons prevents and blocks some of the attractions of nucleus towards the outer electrons. This is a big difference between the inner electrons and outer electrons. That means inner electrons feels the attractions of nucleus completely, and outer electrons cannot feel the complete attractions of nucleus. The net attractions between the nucleus and outer electrons. So decrease the attractions between the nucleus and outer electrons. This is nuclear charge. That means the inner electrons feels the attractions of nucleus. Nuclear charge is denoted by Z. The effective nuclear charge 2.69. For example, I am saying the outer electrons feels the nuclear charge attractions 1.89. This is the concept, nuclear charge. Nuclear charge means the net force attractions between the nucleus and outer electrons, but inner electrons feels the attractions and experiences the attractions of nucleus completely, and outer electrons cannot feel completely. The decrease in attractions between nucleus and outer electrons is nuclear charge. Here period 2, the size is remains the same from the left to right. So what happened here? Nuclear charge attractions are increases. Why? Because increases. The size is small, then definitely the attractions between the nucleus and outer electrons is increases. If the size is big, let us consider about this. If the size is big, so the attractions between the nucleus and outer electrons is decreases. Attractions. Here the attractions is decreases. Why? Because size is increases. But here the size is small, remains the same from the left to right. So if the size is small, then obviously the attractions is high. So here period 2, the elements or the size of the elements from the left to right is remains the same. Size is remains the same means attractions between the nucleus and outer electrons is increases. So that's why in period 2 nuclear charge is increases. That's why atomic radius is decreases from the left to right. In group size is increases. That means nuclear attraction is decreases. That's why atomic radius is also decreases. You have to remember, if the size is inversely proportional to nuclear charge. If the size is increases, nuclear charge is decreases. If the size is decreases, nuclear charge is increases. Atomic radius concept is totally depends upon the nuclear charge. So in groups, from the top to bottom, size is increases. Size is increases means attraction is decreases. But in periods, size is remains same. That's why attraction is increases. This is a big difference between the groups and periods. That's why atomic radius is increases in top to bottom in groups. In periods, atomic radius is decreases from the left to right. The size of the elements is like this in groups. The size of the elements in periods like this remains same. This is a big difference between the groups and periods. Thank you for watching.